Hello class, good afternoon. And we start with comparison of allowable and actual stresses. Dito meron tayong stages sa post-pre-stress. Meron tayong transfer stage tsaka service stage. Sa transfer, ito yung time na yung tendons doon mo siya binabatak and then ire-release mo siya to the point na ma-apply yung pressure sa I-beam. And then sa service stage naman, ito yung stage na nag-a-apply na yung mga long-term losses. Dito sa transfer, take note, ang applicable dito yung short-term losses. Okay? Sa service, ito na yung mga long-term losses. So, yung service stage, this one occurs after several years na. Okay, so dito sa transfer stage, meron tayong stresses sa tensile tsaka sa compressive. And then, you look here at the subscript, you have CT. Okay, CT stands for concrete transfer. Dito naman, sa concrete stresses at service stage, you have the subscript CS. That stands for concrete service. So, sa subscript pa lang, makikita mo na kung anong stage yan. And then, yung third subscript, yung small letter, FCT, and then small letter T, stands for tensile. Dito naman, FCT, and then small letter C stands for compressive stress. Now, let's look here at the equations. For concrete stress at transfer at the tensile stress, the actual equation is negative initial force times the quantity 1 all over area gross minus YB minus D2. Ito yung distance nung tendon from the neutral axis all over section modulus at top minus moment due to girder weight, ito yun, all over section modulus at top. Okay, so let us do this in Excel. Okay, so here we go. Equal sign, and then negative, and then this is initial force. Nandito yan sa short-term losses. Ayan, okay, so initial force. Take note that this is in kilonewton, so you have to multiply that by 1,000. And then, open parenthesis, 1 all over area gross. And that is found in the basic section properties. Okay, tapos, minus the quantity, dito na tayo, YB minus D2. So, yung YB, nandun din yan sa basic section properties. Ito. Then, minus D2, that is distance. Ayun siya. Okay. And then, close parenthesis, divided by section modulus at top. And that is found also at the basic section properties. Ayan. Close parenthesis. Minus moment due to girder weight. Nandito yan sa design moments at midspan. Ayan. Moment due to girder weight. And this is in terms of kilonewton meter. Kaya, imumultiply natin siya kaagad ng 1 million para maging Newton millimeter divided by section modulus at top. That is in basic properties again. Then, enter. So that is negative 0.47. Check natin. Ayan, okay? So, parehas sila. So, yan yung tama yung equation natin. Next, is yung allowable tensile stress is equal to negative square root, open parenthesis, F prime CI. Ito, 28. Then divided by 4. And you have 1.322. Let's uncover this and check. Yan. Okay, so para sila. Next is, i-check natin yung kung safe siya. So, ang para ng pag-check dyan is equal to if the allowable stress is greater than the absolute of the actual stress, then you print safe. Otherwise, you print fail. Yan. Okay? So, yung absolute value ng negative 0.47 is 0.47 and allowable is 1.32. Therefore, it is safe. Next is dito tayo sa concrete stress at transfer for compressive, FCTC. Ito siya. So, the actual is negative 1F, 1 all over AG plus YB minus D2 all over SB plus NGW all over SB. Notice na parehas lang, halos similar sila dito sa FCTT, di ba? Nagkaiba lang sila dun sa sign. Ito, negative, dito positive, tapos this one is negative, and then here positive, and then yung section modulus, bottom ang gagamitin natin. Okay, so all we have to do is, let's try to copy this. Or, you can do it the long way. No? And then, i-trace natin mamaya yung difference. So, first, ayusin natin yung signs. Ito, gagawin nating positive. Ayan yun. So, this one is positive. Tapos, ito naman, magiging plus. Ito siya, plus. And then, yung S sub T, okay, magiging S sub B. All you have to do is to scroll up hanggang makarating ka sa S sub B. Ito siya. Ayan. So, all you have to do now is yung S sub T, click mo lang yan, then drag mo sa baba. And then, i-press enter. And then, dito naman sa allowable, it is 0.55 F prime CI. And then, notice na parehas lang sila na F prime CI. Okay? So, all I have to do would be check this. So, G13 siya, no? So, equal to 0.55 times G13. Yan. So, hindi ko na kailangan mag-scroll up pataas. Now, let me check. So, uncover ko yan. O, see? Parehas sila. And then, now let's go to concrete stresses at service stage. Dito na tayo. Ito medyo mahaba. Pero, may similarity siya dito sa concrete stress at transfer dito sa tensile. Okay? Take note na meron siyang 1 all over area gross, tapos YB minus D2 all over section modulus top. And then, yung girder weight, nadagdagan ng moment due to SLL. MDSLL. Ano yan? Oops. Sorry. This is MDSH or moment due to diaphragm slab, and haunch. And then here we have MFSP. This is moment due to future wearing surface, sidewalk, post, and railing. And then MTLL, moment due to traffic live load. So may mga subscripts yan. Okay, tapos in here you have S sub B and then S sub BC. Okay, so let's try. So dito tayo sa concrete stresses at service stage dito sa compression. Okay, so ito siya. And then dito tayo. Ang gagawin natin this time, balik tayo sa umpisa. Okay, so equal sign, i-trace natin si negative EF, ito yun, negative effective force, then multiply that by 1,000 times the quantity 1 all over area gross. Ayan. Okay, tapos nasan si area gross? Nasa basic section properties, minus, okay, this is minus, open parenthesis, YB minus D2. Nasaan si YB? Katabihan or nasa ilalim ni area gross. Minus D2. Ito siya. All over section modulus top. Okay, ayan siya. And that is in gross basic properties. Ito, okay? So, S bottom section modulus and then close parenthesis. Lagyan ko lang ito ng space minus. Dito na tayo ngayon. So, moment due to girder weight. Nasaan si moment due to girder weight? Nandito yan sa at mid span. Okay. Moment due to girder weight, 1858 plus moment DSH, moment due to diaphragm, slab, and haunch. So, this is, ayan. And then, close parenthesis. And then, this is kilonewton meter. So, you have to multiply this by 10 to the 6 or 1 million. Divided by S sub T, section modulus top. Nandito yan sa basic properties. Ito. And then, space ulit. Minus, open parenthesis. Dito na ako sa future wearing surface. And then, slab, post, and railing. Nandito yan. Katabihan ni moment due to girder weight, ito. And then, plus, moment due to traffic live load. So, nandun yan ngayon sa baba. Okay, dito sa moment due to traffic live load. Ito. Okay? Hindi yung truck loading, hindi yung lane loading, but moment due to traffic live load. And then, multiply this again by 1 million. Okay. And then divided by STC. Nandito yan sa composite section properties. Then you press enter. Okay, so let's check. Negative 9.046. So, mali. Saan ako nagkamali? So, i-trace natin, ano? O, ganito ang pag-trace. So, I will press F2. Negative F237, that should be, ayan, effective force, 237. Ito yun. Tama. Okay? So, this is column F, and then, row 237. Next, 1 all over area gross, yung G74. Ito siya. One all over area gross. Ayun, tama siya. That is G74. Ayan, okay, G74. And then dito na tayo ngayon sa YB minus D2. That is G75 YB minus D2. Ayan, that is G40. Correct. All over G79. That should be your S sub T. Okay, so let's check. G79 S sub T. Ayun. Okay, dapat ito G78. So, ang gagawin ko dito, yan ang ikiliklik ko. Gagawin ko lang tong 78. Next. Dito na ako ngayon sa moment girder weight plus moment due to diaphragm, slab, and haunch. And this is G121 tsaka G122. Ayan. Okay. 121 tsaka 122. Next is all over G78. Again, that is S sub T. Okay. So, parehas sila. G78, G78. And then, ito naman, let's check. Anyway, I will now press enter. 9.05. Ayan. Okay. So, that's how to check. Ngayon, dito na ako sa allowable 0.4 F prime CPC equal to 0.4 times F prime CPC. Ayan siya. And then, I will press enter. Then, let's check again. I-unhide ko na lang yan. Okay, so, parehas na. Next, dito na tayo ngayon sa tensile stress. Okay, ito, medyo mahaba. This time, let us compare itong actual FCSC dito sa FCST. Meron siyang negative EF, yung section modulus niya from top, gagawin nating bottom, ano? Then yung moments niya, parehas lang. Okay? So, all I have to do is simply copy this again. Control C and then paste here. Ang papalitan ko lang yung section modulus top. So, nasan yan? Ito. Ayan. So, gagawin nating ayan. S sub T, gagawin nating S sub B. Pwede ko lang i-click yan pababa. Okay, so dito, pwede mo rin siyang ma-check. This is G79. This is column G and then row 79. And that refers to section modulus bottom or S sub B which corresponds to this. Okay, next. Check natin ngayon yung signs. So, I'll press enter. Dito, so that is negative, negative, and then sa loob, ito naging negative going to positive. So, ito siya. Gagawin ko itong positive. Next, ayan, this is negative, magiging positive. Ito yun. So, gawin ko yung positive. Tapos, ito plus, plus, and then ito naman, this is negative to positive, which is this one. Then, I will press enter. Tapos, ito naman, allowable is square root of F prime CPC. And, eto may F prime CPC rin. So, check ko lang. And that is G12. Okay? So, equal sign square root of G12 close parenthesis divided by 4. Then I will press enter. Now, let's check. Whoops! 1.47. Mali na naman ako dito sa tensile stress. Okay, saan ako nagkamali? So, probably, etong huli. This is G102. And what is that G102? That is STC. This is composite section modulus at top. Okay. Composite. Ayan. This should be bottom. So, SBC. Yan. So, i-click ko lang yan pababa and then I will now press enter. Okay? So, parehas na sila. Yan. So, ganun ang pag-check. Kung meron kang pag-checkan. So, it is better na gawin mo na lang na mano-mano. Huwag ka nang mag-copy-paste, something like that. Mas malilito ka lang. So, dito na tayo ngayon sa top slab compression. And equal sign, negative, open parenthesis, moment due to future wearing surface, and SW nasan ka? Ito. Plus moment due to traffic live load, and then close parenthesis. Let's multiply that by 1 million to convert this to Newton millimeter, and then divided by STC prime. Yan yung section modulus of top slab. Makikita yan sa composite. Ayan. Okay, so this is your composite section properties. STC prime, and then enter. Next is divided by the modular ratio. Okay, so ang gagawin ko ngayon, i-parenthesis ko lahat yan. Divided by modular ratio, nandun yan sa composite properties. Ito, N. And you have negative 2.48. Tapos, 0.4 F prime C equal to 0.4 times F prime C, nandun yan sa taas. Ito siya, si 21. Then, let's check again. Unhide. Yan, see? Parehas. And then, at jacking stage, what I'm doing here is, I'm just showing you na itong notes is correct. Dito na tayo sa jacking stage. So, your actual stress is simply equal to your jacking stress, which is here at before sa short-term losses. Ayan. Okay, so that is megapascal. And then, the allowable is 80% of FPU equal to 0.8 times FPU. Nasa taas siya. Ayan. Then, enter. And then, dito na tayo ngayon sa at transfer. So, this is jacking stress equal to JS, this one, this is megapascal already, minus delta FPA. This is anchorage loss, okay, which is 39.1020. Okay, so minus, click mo lang yan. And then, dito na tayo sa minus 900 times jacking force, then times 1 all over area gross. Nasaan si area gross? Nasa basic. Ito. Minus YB minus D1 squared. Okay. Careful here. Okay. That is YB minus D1 squared. So, open parenthesis. YB minus D1. Ito siya. Yung 875. And then, arrow up squared divided by gross moment of inertia, IXG. And then, press enter. Tapos, the allowable is 70% or of FPU. And that is G15, no? So that is 0.7 times G15. Okay, so let's uncover and check if it is correct. Yan. Okay? So, ibig sabihin yan, correct yung ating equations. Now, let's go to ultimate moment capacity. So, i-delete ko na ito. And then, itong comparison kanina, all I have to do is to copy this, paste, 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 paste. Okay. Dito na tayo ngayon sa ultimate moment capacity. So, probably, this would be our last lecture sa pre-stress concrete. Ang assumptions natin dito sa ultimate moment capacity is parang singly reinforced beam siya, ano? Lahat ng rebars nandun sa ilalim. And pre-stress siya. Ibig sabihin, gumagamit ka ng strands tsaka FPU. Singly reinforced in the sense na hindi tayo maglalagay ng bakal dito sa taas. Okay? Aside from that, T-beam din siya, no? Ibig sabihin, yung mga flange concrete, kagaya itong slab, i-consider natin siya as part of the compression area. So, ang kailangan natin dito, yung section is the effective with BE, tapos yung depth, okay? And then, depth is simply the distance of the rebars and pre-stressing tendons from the top of slab. And D is equal to D1, yan yung overall height of the girder, plus thickness of slab, plus thickness or height of the haunch, minus D2. Okay? Take note na yung D2, yan yung centroid nung pre-stressing strands from the bottom. This is at mid-span. Okay? Tapos yung AS, yan yung area of rebars. Okay, take note, rebars, hindi kasama dyan yung strand. And then, assume rebars and strands yield. Kaya mapapansin nyo na, ginamit na natin dito yung yield stress ng AS tsaka yung ultimate stress ng strands. Okay? FPU. So, I take this as T prime. And then, this is equal to AST times NST times FPU. Yung AST na yan, that is the area of strand. Yan yung 98 point something. NST, that is the number of strands. Tapos FPU, yan yung ultimate strength ng strand. Tapos, etong CF, this is the compression force due to the slab. Okay? Minus the hunch bottom width. Okay? So, this is 0.85 F prime C. Yan yung mga nandito sa labas. Okay? BE, effective width minus hunch bottom width multiplied by TS. In short, yung F, parang subscript yan for flange. And then here we have FSU star. Okay? So, equation yan is equal to FPU times the quantity 1 minus 0.4 all over 0.85 times T prime divided by D times BE times F prime C. Okay, now let's go to the computation. So, ito yung mga existing. Co-cover ko lang yan. And then I will block. Papakita ko na tama yung ating equations. So, dito ko gagawin. Equal, and then this is D1, ano? Punta tayo sa dimensions. Ayan. Take note na kailangan natin yung millimeter, natin yung 72 inches. Ayan, D1. D1 plus thickness of slab ito siya, ayan. Okay, slab thickness 180, and then plus HT or height of the hunch thickness 100 minus D2. Okay? Minus, nasan si D2? Ito. Then I will press enter. Para sa AS naman, that is the number of bars. Ayan. It is the number of bottom rebars. Take note, NB is number of bottom rebars. So, ito yan. Yan yung 25 mm. Okay? Nasa given date yan. Number of bottom rebars, ayan yun. So, 5 pieces times pi times d square divided by 4. So, meron na tayo AS. Yan, cover ko lang yan. Check kung tama. Okay. So, correct. And then, for T prime, dito na tayo. This is equal to area of strand. Nandito yon, area of strand. Yan, yung 98.709, that is input data. Tapos, multiplied by number of strand, yung 48. Multiplied by FPU. Ito, 1862. Plus ASFY. Nasaan si AS? Yung kasosolve lang natin kanina. Ito siya, no? So, ayan. Times FY. Nasaan si FY? Given data yan. Yan. 276. FY is the yield strength of rebars. And then let's compare. So, parehas sila. Next, dito na tayo sa compression force due to flange. So, equal sign. And then, that is 0.85 times F prime C. Times the quantity BE, effective width, nandito yan sa composite properties, Ayan. Minus HBW, that is haunch bottom width. Dito yan sa given. Ayun. And then multiplied by thickness of slab, TS. Yan. Then I will press enter, and that is kilonewton, kaya i-divide ko siya ng 1,000. Okay, so let's check kung tama yung equation. Oops, okay, 4604 yung tama. Saan ako nagkamali? So let us trace. Compression force 0.85 F prime C. F prime C should be G13. Okay. Yun. It should be G14. Yan. O, yan. See? Tumama na. Next. Dito na ako ngayon sa capital T. So, this is now FSU star. Pero, yung FSU star, ito yun. This is on the assumption that rebars and strand yield. We will compute that. So, i-cover ko lang ito. And then let's compute now FSU star. So this is equal to FPU ito siya times the quantity 1 minus open parenthesis 0.4 divided by 0.85 close times open parenthesis, then T prime. So punta ako ngayon sa T prime. Nasaan siya? Ito. Note na Newton na siya, so you don't have to multiply it by anything. Divided by the quantity, ayan na, D times B times F prime C. Ito si D times B effective times F prime C. Nasa taas. Ayan, 21. And then, close parenthesis. Okay, so 1783. So, correct siya. And then, we now compute your capital T. So, here. Equal sign, FSU star. So, I will just click here. Note na si FSU star is already megapascal. You don't have to multiply that by anything. Then, multiplied by area of strand tsaka number of strand. Dito yan sa taas. And then, this is the number of strand plus AS FY. Okay? So, unahin ko na si FY. Yan yung 276. Times AS. Ito siya. Then, I will press enter. Notice na nag-sharp siya. Ibig sabihin, kulang ng space. So, I will divide this by 1,000 para maging kilonewton. Yan. So, 12,306. Now, let me compare 9125. Something's wrong again. So, click ko yan. I will press F2. Saan ako nagkamali? So, going back here, T is equal to FSU star. Ayan, di ko na i-click. Ayan, no? A264, nandito siya. This should be F264. So, papalitan ko lang yan. Then, highlight. I-click ko lang yan. Then, let me check again. 9125. Ayan. So, tama na. Next, TW, this is the tension force that is equal to capital T minus CF. That is 4520. Let's uncover. Okay, tama. Next is, dito na tayo sa A. Okay? Ito yung theoretical location of the compression block. Ano? Assuming that everything yields. And that is equal to, open parenthesis, dito na tayo ngayon, FSU star multiplied by the area of pre-stressing tendons. Ano? So, AST times number of strands. And then plus AS FY. Unahin ko na si FY times AS. Ito siya. Then close parenthesis. Nandito pa lang ako sa numerator. So I will divide this by open parenthesis 0.85 times F prime C tsaka BE. Nasaan si F prime C? Nasa taas. Ito. And then BE, effective width, nasa composite. Ayan. Close parenthesis and then enter. Now let's check if parehas. 237. Mali na naman. Okay, so i-trace natin. Again, meron tayong equations dito. So, F264, tama, FSU. And then, J38 tsaka G37. Ito yung pre-stressing strands. Ayan, ano? And then, plus ASFY. Si FY, 16. Ayan, yan yung G16, okay? FY, tapos A264, si AS. Okay, ito yun. Divided by 0.85 F prime C and BE. Oh, mali. Mali yung lugar ko. Dapat itong equation na yan, cut ko lang. Dito yan. Okay? Yung A, ito ang kino-compute pala natin. Sorry. So, I will paste here. Dito ko siya i-compare, ano? Yan. Because this is cover ko lang ulit yan. Sorry. Yan. So, i-compare ko yan. Dapat tama na yan. Yan. So, parehas. Now, we will check if A is less than thickness of slab, then analyze as rectangular beam. Okay? Nasaan ngayon si thickness of slab? If, open parenthesis, A is less than thickness of slab, Nasaan si TS? Ito. Then, print analyze as rectangular beam. Otherwise, analyze as T section. Okay? Yan. Okay, so analyze as T section natin siya. Dahil ano ba yung value ng thickness of slab? Di ba? Thickness of slab is 180. Okay? Yan. At ang na-compute natin ay 204. Yan. So, it is greater than thickness of slab. Kaya, analyze as T-section. Ngayon, tamang-tama, etong ginawa nating equations, this is designed for a T-section. Okay? Why? Because dito sa pre-stress concrete, rarely na nag-o-occur na A is less than T. Okay? In short, kapag nangyari na A is less than T, analyze as rectangular beam, hindi na applicable itong mga true value of A, so forth, and so on. Okay? As I've said before, it rarely happens na A is less than T. Okay, so let's continue. We now compute for the true value of A. And that is equal to TW. So, i-click ko lang yan. Multiplied by 1,000. Divided by the quantity 0.85 times F prime C tsaka HBW. Nasaan siya? Ito. And then, close parenthesis. And I will press enter. So, 237.40. Let's check. Tama. We now go to computation of capacity moment. So, this is the ultimate moment capacity using the true value of A. So, this is equal to 0.9. Yung 0.9 na yan yung capacity reduction factor Phi for flexure. Okay? Times, open parenthesis, CF. Ayan. Notice na this is kilonewton, so I will multiply this by 1,000. Times the quantity D minus TS all over 2. Ito si D. Minus thickness of slab. Ito. Divided by 2. Close parenthesis. Plus TW. Dito na tayo. Okay. Si TW naman, ito siya. It is in kilonewton, so I will multiply this by 1,000 para maging Newton. And then, multiplied by the lever arm na D minus A over 2. Ang gagamitin nating A yung true value. Okay? So, D minus, ito na, 204 divided by 2 and then close. Isa pang close. Tapos, we divide this. Make sure na i-divide mo yan ng 1 million. Yan. So, 15,709. Okay, so let's check. Dapat, ang ginamit natin dito ay yung true value of A, okay? Hindi ito, kundi itong 237. So, ayun, nakalink siya dito. So, dapat nakalink siya dito sa 237. Okay, let's check. 15,642. Ayan, parehas na po siya. And then, let's continue. Dito na tayo ngayon sa load. Ito yung M sub U. It is 1.3 times the quantity MD, moment due to dead, plus 1.67 due to live load. Pero itong moment dead, ang composition niyan, yung girder weight, diaphragm, slab and haunch, tapos future wearing surface, post and railings, and then yung live load, yan yung traffic live load. Okay, so let's compute that. And then dito, factored moment, ayan yung MU, equal to 1.3 times the quantity, dalawa, para sa moment due to dead. So that is moment due to girder weight plus yan, diaphragm, slab and haunch, plus eto G123, and then close parenthesis, plus 1.67 times moment due to traffic live load. Ayan po. And then close parenthesis, 97.55, and correct. Okay, next is i-compare na natin si capacity MU sa ating moment. Ano? Dapat yung capacity MU is greater to your load, which is multiplied by 1.2 or with extra 20%. So to do that, if dito tayo, if open parenthesis, capacity MU ito is greater than 1.2 times MU, then print save, otherwise fail. Okay, ulitin ko lang. If capacity MU ito is greater than 1.2 times factored moment, then print save, otherwise you type or print fail. Yan. Okay, so ang 1.2 nitong factored moment is 11,706, and ang ating ultimate moment capacity is 15,000. It's still greater than 11,000. So okay lang, safe pa rin siya. Next, dito na tayo ngayon sa check cracking moment. Okay, so FR, this is something about rupture. Okay, so yan. And that is equal to 0.62 times square root of F prime CPC and then close. And then our cracking moment. First, we have to compute our MCLR. MCLR is equal to, ito siya. So, FR plus EF, effective force, and that is in kilonewton, kaya multiply natin siya ng 1,000 para maging Newton times the quantity 1 all over area gross. Plus YB minus D2 and then close, divided by, dito na tayo sa S sub B, ito siya, then close, minus moment due to girder weight plus moment due to diaphragm, slab, and haunch, close parenthesis, multiply that by 1 million, and then divide by SB, that is section modulus bottom, gross, using gross, ito. And then, close parenthesis, multiply that by your transformed bottom section modulus, SBC. Ayan. Okay, next is, but this is in Newton millimeter, kaya i-convert natin siya ng kilonewton meter. So all you have to do is divide this by 1 million para maging kilonewton meter. So let's check. Ayan, so it is the same. And then, we can now compute your cracking moment, MCR. Okay, so dito tayo, equal sign, and then MCLR, ito siya, plus moment due to girder weight, plus moment due to diaphragm, slab, and haunch, and then enter. Then let's check again. Okay, so dapat yung capacity MU should be greater than 1.2 cracking moment. Okay, so if capacity MU is greater than 1.2 times MCR or cracking moment, then you print safe, otherwise fail. Okay, so let's check yung cracking moment. Ayan, so parehas. Okay, so 7,323. Okay. So, naipakita ko sa inyo guys na yung ating equations dito ay correct. So, ngayon tatanggalin ko na itong mga trial ko. And then this and this. Tanggalin ko yan. Remove this. Okay, so that's it. I will share this with you and then you can test it for yourself. And thank you guys for listening. Actually, hindi lang nagtatapos dito sa ultimate moment capacity. Meron pa siyang spacing of shear reinforcement, tapos camber calculations, then tendon profile, and then this is your cable layout, tapos camber diagram, so forth and so on. But we will not be taking this anymore. Masyado nang complicated yan. Hanggang dito lang tayo sa ultimate moment capacity. Okay guys, thank you again and keep safe and God bless us all. Thank you. Bye-bye.